So we have inverse variation. Beginning of chapter 8. We have to remember what direct variation was. Direct variation had a simple formula that was y equals k times x, where k is a constant. So basically, equations that are direct variation equations are going to be linear equations that go through the origin, which is how we defined it before. Because an example of a direct variation equation, y equals 3x, where our k value is 3. And in a direct variation, if the value of x increases, the value of y will also increase. Not by the same amount, but according to this factor here of 3. So direct variation means if one of the values increases, the other one will increase as well. Inverse variation then, if one of the values increases, the other value must decrease. And vice versa. If one goes up, the other must go down. And the formula for that you can think of in two ways. Direct variation, I think this is the easiest way to think about it. Inverse variation, sometimes there's a choice. You can say x times y equals k, or you can think about it like y equals k over x, or you can switch the x and the y there. You can say x equals k over y, where again, k is a constant. So an example of something like this, y equals 4 over x. And so hopefully from this example you can see if the value of x gets very large, the value of y is going to get very small. If x is 1, y is 4. If x is 4, y is 1. If x is 16, y is 1/4. So as x is getting bigger, y is getting smaller. And that's the main difference between direct variation and inverse variation again. Direct variation, they will both increase or both decrease. In inverse variation, they will go opposite directions. One goes up, one goes down. Two tables. That screen is glitching up something fierce, isn't it? Wow, I don't like that at all. We'll go with it. Okay, we have two tables. Part A, Part B. Our goal is to determine, do those table of values represent a direct variation, an inverse variation, or neither? So the first thing to think about, if both values are increasing or both values are decreasing, then it could be direct variation. If they're going in opposite directions, it could be inverse variation. So part A. As the x's are getting larger, the y's are getting smaller. So that might be inverse variation. We would have to make sure that there is that constant k that remains the same. So we have to remember, oh, the glitching stopped there, and now it has stopped there. Hooray! So, we know that our formula is x times y equals k. So let's take this first point. 152. 1 times 52 is 52, correct? Yeah, we should all agree with that. Take the next point, 2 and 34. What's 2 times 34?
41.2.
68.
Okay.
So is this number right here constant? No. So part A is going to be neither. It can't be direct because as the x's get larger, the y's are getting smaller. So no way it can be direct variation. And then there's not a constant involved here, so it's not inverse variation. Part B, as the x's are getting larger, the y's are getting smaller. So let's check. Same thing we did up there. What is 0.2 times 0.8? 1.6. What is 0.4 times 0.4? 1.6. What is 0.5 times 0.32? 0.16. And these ones should be 0.16. 0.16 and 1.0 times 0.16, 0.16. So part B, that is going to be inverse variation. And then there's another little rule that the book gives you. How can you determine between direct and inverse? If the product of the x and the y's is constant, then they vary inversely. That's what we just did right here. The products are all 0.16. And then for direct, if the ratio of the x's and the y's is constant, then they vary directly. Suppose x and y vary inversely, and x is 2 when y is 8. So right off the bat, I'm going to say inverse variation means x times y equals k. They tell us x is 2 when y is 8. So what is k? 16. So we know that x times y needs to be 16. So what is the function of the inverse variation? We want to take this right here, and we are used to having y equals. So y equals 16 over x. So that's part A. Part B, what is the graph? To find the graph, we just want to plot points. If I plug in 0 right here, I get undefined. And we get a vertical asymptote right there. If you plug in 0 and get undefined, you get a vertical asymptote, meaning the graph is going to get incredibly close to this vertical line, but it's never actually going to touch it. Now, what if I plug in 1? So if I plug in 1, I get 16. That's this point right here. Let's say each block on my graph is 2. So I went up to the right half a block and then up 8 blocks. If I plug in 2, I should be at 8. Right there. If I plug in 4, I should be at 4. And if I plug in 16, I should be at 1. Right there. And so this graph is going to look like that. It's going to look kind of similar to an exponential decay graph that's just been moved only into the first quadrant. That's not the whole thing though, because I can plug in -1, right? If I plug in -1, I'm at what? -16. And it's going to be a similar scenario here. It's going to be this same piece right here, just reflected into the third quadrant. So it's going to look like that. So that's part B. And then in part C, what is y when x is 4? We already covered that that one is the 0.44. Your employer decides to hire extra help to deliver newspapers during the holidays. The table shows the number of employees who delivered papers each week and the time needed for delivery. What function models this problem? We're doing the section on inverse variation, and you can see that as the number of employees increases, the time decreases, which should make sense. If you have more people delivering stuff, it should take less total time to get it all delivered. And if it were inverse variation, we would have x times y equals k. Looking at that chart, can anybody tell me what the value of K should be? The value of K should be 200 because it should be X times Y. 2 times 100, 4 times 50, 10 times 20, 20 times 10. All of those give us 200. So what function models this problem? Y equals 200 over X. And just as a quick review, we could write that as a function. F of X is 200 over X. Same idea. So that's part A. Part B, how many employees should there be to deliver newspapers in at most 40 minutes each week? So we know that we have Y is 200 over X. When will this at most be 40? We get 200 less than or equal to 40x, so we get that x should be greater than or equal to 5. Right? There should be at least 5 employees. So let's actually do both of them at the same time. Boom. So we have that volume, direct variation is x equals k times y. Inverse variation is x times y equals k. We know the volume varies directly with its temperature and inversely with its pressure. So volume varies directly with its temperature and inversely with its pressure. So it should be K times T and then all over P. So this is combined variation. Does that make sense to everybody? Why the temperature is in the numerator, pressure's in the denominator. So then we plug in what we had at the beginning. 100 is K times 150 over 15. So then K is 10. So then we move on, what is my volume when the temperature is 250 and the pressure is 20? That volume is going to be 125 meters cubed.